So friend, let's start fresh and start with positive energy. And don't hesitate in asking questions, because this is the time when we interact and we share our views, and we also share learning with each other. So you can put your queries in the chat box, or if you want to talk to me directly, you let me know, and the organizers will unmute you and you can directly talk to me. But make sure that you are starting with energy, fresh, and ready for any kind of discussion and debate, whatever you have in your mind. Don't hesitate. Okay, so let's start. And what comes to your mind when you see the following picture? Anyone? You can put your responses. It's a book that represents knowledge.
So can I answer?
Yes, Anshika, you are most welcome.
So nurturing, having a book is not enough. You have to nurture it to grow.
Right. And the fact these people are joining this program, we believe that they are here to nurture their knowledge, nurture their capabilities to learn, and that the purpose of sharing this particular picture with all of you. But to nurture it, you have to water it.
Recording in progress.
When you water it, that means you're putting some efforts. So put your efforts, put your labor, put your mind, put your hard work, and then you will find that the knowledge is flourishing and giving you fruits. Anyway, as a researcher, we are supposed to create knowledge, and for that we have to find out answers for the research problems. Whatever research you are doing, that research should address to a research problem. Every research starts with a problem, which we call as a research problem. And if you don't have a research problem, I'm sorry, you have to think of it, work on it. Once you get the research problem, then you start working on it. Don't work unless and until you identify what are the problems for which you are looking forward answers. Okay? And let's have a look at some of the research issues, and then I would like to know. First, I would like to share with you an advertisement. Enjoy this advertisement.
लेकिन तभी बारिश आ गई। मम्मी ने कहा था कुछ भी हो, भीगना मत। बारिश ने मेरा सॉलिड पप्पू बनाया और अब बीमार भी मैं।
बारिशों में बच्चों को भीगने से रोकना आसान है, पर जर्म्स को रोकना, इसीलिए डाबर च्यवनप्राश। इसमें है आंवला, अश्वगंधा जैसे 41 आयुर्वेदिक हर्ब्स जो बारिश में भी बनाए इम्यूनिटी।
The research issues which have been raised in this context, do you think that such an ad is playing with the psychology of the children to boost the sales of a product? Anyone? What do you think? Is it worth investigating? Yes, Madhu. Those who are working in the area of marketing and advertisement, do you think we should encourage such kind of advertisements, and are they really effective in affecting the psychology of the children and thereby the boosting sales? That is something we have to think, and maybe some would like to work on this kind of problem. Another. Do you believe that when stakes are high, people cheat? Do you see a research issue here and some hypothesis testing? And that's we have taken from a very famous book that's on Freakonomics. That says that if stakes are very, very high, people do cheat. Do you think there is some hypothesis testing involved in it? We have a problem and we want to get an answer for it. Can we generalize this kind of a conclusion that when the stakes are high, people do cheat? Another issue. Look at the following, analyzing the impact of non-performing assets on Indian banks. The purpose of the project is to know how NPA levels affect the profitability of a bank. Do you see any hypothesis which the researchers would like to test? We all know that non-performing assets, NPA, is a real problem. And regulators, banking industry, trying to find out solution for the same. And as a researcher, if somebody wants to see what is the impact of NPAs on the profitability of a bank, do you see any hypothesis involved in it? Ashika, do I have a right to unmute somebody?
Hello, sir. Please, can you repeat your question?
Can I have a right to unmute somebody?
So, ma'am is working on it currently. It will be there soon.
Okay. Okay. Kavita is saying causal relation between profitability and NPA to test, not a hypothesis. Jigisha, why do you say there is no hypothesis? Jigisha, what makes you to say no hypothesis? Anyway, I will come back to this. Some says hypothesis, some says no. We will come back to it before we actually come down to testing of hypothesis. Impact of brand on consumer behavior. The purpose of this study was to examine the impact of brand on influencing consumers to purchase a product. So in that case, do you see any hypothesis which is involved? If you start reading such kind of article, do you think you will come across with hypothesis? Jigisha is saying it's a question, not a hypothesis. Jigisha, my question to you is how to answer that question. How to answer that question, that is something which we have to understand. All this shows an important fact about many researchers, that is, many times a researcher has to confront with hypothesis. Okay, for example, does NPA impact profitability of banks? That's my research question, right? How do I check it? Using data. Without data, I cannot answer this question. I need the data. And when you have the data, you will be using statistical tools to answer this question. And when you are using statistical tool, one of them is hypothesis testing. So a research question has to be converted into research hypothesis, and then research hypothesis should be converted into statistical hypothesis for testing statistically. Kavita is saying through regression. Kavita, right now I'm not looking forward what is the appropriate tool that we will discuss later. But right now we are trying to appreciate the role of hypothesis in research. And Ashika, it is still showing no right. Okay. Can any one of you share me your topic? Any research topic? Madhu, अपना topic बताओ. Others can also share if they want. Madhu, write your topic. IPO underpricing. So my research problem is that we want to know whether IPOs are underpriced when they are offered to the public. Okay. Of course, you need data to prove or disprove your conjecture about IPO pricing. And my research problem is, research hypothesis is, Madhu, what you believe? IPOs are underpriced or not? That's my research hypothesis, which I want to prove by making use of data. To test research hypothesis, I need to convert it into statistical hypothesis. Statistical hypothesis always exist in pairs, null and alternative. Null means what you believe, reject that. If you believe IPOs are underpriced, your null hypothesis will be IPOs are not underpriced, they are properly priced. Alternatively, you will say IPOs are underpriced. That's how we make a distinction between research issue, research hypothesis, statistical hypothesis. Will anybody else like to share the topic? Okay. So friends, please be clear in your mind. There are two different things, research hypothesis and statistical hypothesis. Okay? And in social sciences, you'll find most of the time we are making use of hypothesis testing. And therefore, we should make ourselves capable of doing all kinds of hypothesis testing, whatever research problem we have, whatever research hypothesis we have before us as a researcher. To test the hypothesis, the researcher collects data and uses a statistical tool for hypothesis testing, for proving or disproving research hypothesis. So friends, I hope now you can appreciate the challenges of statistical hypothesis testing, and that's what we are going to discuss in this particular session. So get ready and let's start our journey towards hypothesis testing. First, let's devote some time to revise our basics about hypothesis testing. So whenever we talk about data, we said there are four types of data: nominal, ordinal, interval scale, and ratio scale data. And we already had discussion about it. So I'm not going to discuss it again. If anyone has any query, any doubt, please let me know. And it might be possible that in your research, you have all types of data. Might be possible. So you must prepare yourself to handle all this data. You have to make yourself capable and learn the tools which can enable you to handle all the types of the data. Okay? Anshika, are you facing problem in unmuting?
Yes, so she is sort of, we are having a network issue here, so that's why we have joined it through the phone. So that is why some issue is there.
Who else is helping you?
So I think Ravinder sir is here, if I'm not wrong.
Okay.
Ravinder sir, are you here? So he is not here, sir.
Purushottam, Anjali. Anyway, Anshika, can you do unmute at your end? Do you have a right to unmute the people?
Sir, can you please repeat it once again?
Do you have right with you to unmute people?
Upload the paper.
Unmute. अनम्यूट
Yes,
करने
sir.
का राइट है तुम्हारे पास?
Yes, sir. Yes, sir. Yes, sir.
तो एक Madhu
Whom
Totla.
I have to unmute?
Madhu Totla.
Just a second, sir.
And if anybody else wants, raise hands.
I think she'll be able to speak, sir.
Yes, sir, I'm unmuted.
Okay. One person has raised hand. Who is that?
Just a second, ma'am.
That raised the hand.
Ma'am, you can
Good evening.
ma'am, you can speak.
Yeah, good evening, sir.
Good evening.
Yes, sir. My topic was the impact of COVID-19 on financial status and mental health of auto rickshaw drivers.
Okay. So what is your question?
So on this financial status, how can we? I have checked the age impact and the number of years on the financial status of auto rickshaw drivers, and financial status and mental health of auto rickshaw drivers I have checked. So anything else I can do in this? So please help me.
Vinaji, I have to first understand your problem because what you said, you have given me partial information.
Okay,
So
okay,
I
sir.
really don't know what
Hello?
kind of questionnaire you are, what kind of questionnaire you are administrating to get the information. And what are your research objectives? Even I don't know that. So given that, it may not be possible to tell me whether your study is complete or yet you have to do something more. I'm sorry. Okay, who else? But of course, Vinaji, in your case, you might be having some of these hypotheses which you would like to test. Okay, so for example, do you think age has an impact on the mental health of the people? So my null hypothesis will be age is having no impact on the mental health of your auto rickshaw people. So like this, I think, Vinaji, you have to make a lot of hypotheses which you have to test, and tool will, of course, will depend upon the kind of the data which you have collected. Anybody else? Okay. When we talk about hypothesis, we define it as formally stated expectations about how a behavior operates. Charu is saying if we are using net assets, market share, size, etc. variables, it's a ratio data. Yes, Charu, you're right. These are all examples of the ratio data. Hypothesis is a tentative guess about a behavior or a relation. It's a proposition that a researcher wants to verify. It's a conjectural statement of the relation between two or more variables. What is that you want to check and you want to test? That will be put on test. That is your hypothesis. Do you see any similarity between a judge and a statistician? Is any participant teaching statistics? Anyone from statistics? Okay. Kavita, I know you teach econometrics. So do you see a similarity between a judge, the way the judge decide to think, and the way a statistician decide to think? Concept of innocent, yes, Riddhi, concept of innocent until proven guilty, right? And the statistician also assume that his hypothesis will remain true unless and until data gives evidence otherwise. So both proceed with the assumption. Judge proceed with the assumption that the person standing before him is innocent till that person is proved to be guilty. The statistician believe that his null hypothesis is true unless and until the data proves otherwise. Both decide on the basis of evidence. And how to dig deep to find fact, that is when you say, Madhu, how to dig deep, that means how to get evidences. And evidences comes from the data which they are trying to get. A judge proceeds with the assumption that one is innocent till evidence proves it otherwise. The statistician also believes that his or her assumption is true unless and until the sample information proves otherwise. Both follow the same method of proving. Both proceed with the assumption that their hypothesis is true. Gather evidence and analyze it. Gather evidence there, Madhu, people can go deeper and dig the evidences and then analyze the evidences, analyze the data, and finally come out with the conclusion whether those evidences forces you to reject your hypothesis or not. And these are the basic elements of the hypothesis testing. You have to formulate a null, then alternative, take a test statistics, that may be your Z, maybe T, maybe chi-square, maybe F, maybe some other. Then you have to specify level of significance, which is normally used 5%. But in some cases, you will find people are using 10% and 1%. These are the thumb rules, no scientific reason behind them. And it's a practice which is being followed widely throughout the world. Then we define a suitable decision criteria based on the value of alpha and test statistics, do the calculations, make necessary assumptions, and come out with the conclusion. So these are the steps which are involved in hypothesis testing. Anyone having any query, any question here? So hypothesis, I've already defined formally stated expectations about how a behavior operates. Null hypothesis means assumption of no change, no effect, one that nullifying the impact of the experiment, one that maintains status quo. And when null is rejected, what is true, that will be your alternative hypothesis. Test statistic is a statistics which is calculated on the basis of sample data that will follow a particular sampling distribution, and then on the basis of that test statistics we decide whether a null is to be accepted or not to be accepted. Level of significance represent the probability of rejecting a true null hypothesis. And level of significance always represents your tail area. So if I say 5% is my level of significance, this will be my 5%. Rejection reason. And this will be your acceptance reason. Decision criteria is the value of a test statistic beyond which observed value of test statistics provide a decision, that is, reject null hypothesis. And every test have tails, one tail test and two tail test. And that depends upon the direction of your rejection reason. If your rejection reason is on one side, we say one tail. If it is on both the sides, we call it two tail test. And then whenever you do hypothesis testing, that decision is subject to certain errors. It might be possible that a true hypothesis is rejected. If it is so, I commit an error. A false hypothesis may be accepted. That's another kind of the error which we are committing. The first one is called type 1 error. And it is represented by alpha. And it is defined as the probability of rejecting a true null hypothesis. Type 2 error represented by beta. And it is defined as the probability of accepting a false null hypothesis. Type 1 error is simple to determine and is always equal to level of significance, while type 2 error is a bit difficult to determine. So if H0 is true, accept, no error. H0 is not true, reject, no error. So if H0 is true and we have rejected, we commit a type 1 error. If it is not true, false, and we accept it, we commit type 2 error. And please remember, alpha plus beta is always equal to anybody. Alpha represents probability of type 1 error and type 2 represents probability of type 2 error. Ganga Sushil is saying not equal to 1. And Ritika Verma is saying 1. Any third person? Break the tie. Anyone? Anybody else? Riddhi, Kavita, what's your opinion? 1 or not equal to 1? Ritika, why do you say it's always equal to 1? Ritika, why do you say it's always equal to 1? Ashika, is it possible for you to unmute everyone?
Yes, sir. Yes, sir. I try.
वो सबको ही unmute कर दो, फिर वो तुम्हारा problem ही खत्म हो जाएगा.
Sir, I have given powers to everyone. Now they can choose to unmute.
That's great.
Thank you, sir.
That's great. I think Ganga Sushil, right? That person is right because there are possibility. The error term which we have, these are 2 possibilities out of 4. And therefore, the sum total of alpha beta will never be equal to 1. It will not be equal to 1. So you cannot say that it will be always equal to 1. धनराज
सर
अनम्यूट करो अपने को या कुछ कहना चाह रहे हो आप? Okay. Then we talk about what is called, power of a test. Power of a test is defined as 1 minus beta. That is the probability of rejecting a false null hypothesis. And as you increase sample size, your power of test increases. That means your chances of rejecting a false null hypothesis increases. And that's one of the reasons why we say that we should take larger samples. We have other advantages of large sample, but this is also one of the advantage of the large sample. As n increases, my power of the test also increases. And there are different ways to decide whether a null is to be accepted or rejected. So for example, we know that if we have a two-tailed test, and we are using Z, we know that critical value of Z will be 1.96. Any value more than 1.96 means we have to reject our null hypothesis. This is one way of deciding it, but these days we work with the p-value or the probability value. Anyone, what is probability value or the p-value? What is it? And these days, every software throws out the probability value, and we take a decision on the basis of probability value, whether null is to be rejected or not to be rejected. Anyone? Like to say something about probability value? Probability value is the probability of observing a sample outcome even more extreme than observed when the null is true. So when you say more extreme, so basically I'm referring to tail. And probability value is always a tail probability. The smaller the p-value, the smaller are the chances that variations are caused by chance or random factors, and hence it should be rejected. Observed level of significance, that's what we call sometimes. Alpha 5% is what you have suggested, and what data suggests, that is observed level of significance, which is equal to p-value. It provides an alternative way to decide whether a null is to be accepted or to be rejected, and most of the software gives the p-value on the basis of which you can decide whether null is to be rejected or not to be rejected. P-value indicates the probability that results are due to the sampling error or chance, and this is always in tail. And if p-value is greater than alpha, don't reject. Your null hypothesis. a p-value is less than alpha, reject null hypothesis. So these are some of the basics which we are trying to refresh ourselves with these concepts so that we can move forward with solid foundation. Anyone having any question, make sure that you are getting clarity about the things. Don't hesitate in asking questions. This is the time when we can get our doubts cleared. You can talk to me directly if you wish. You can put your queries in the chat box, but make sure that you get clarity of the things. No questions? Okay. So So let's move ahead with our discussion on hypothesis testing. Whatever test you are using, every test will be either a parametric test or a non-parametric test. Kavita textbook, if you find, you can pick up a good book on the statistics. And one of the good book which I normally suggest is Keller-Gerald. That's a very good book on the statistics, which every researcher should refer. Two-tailed test was we need to divide alpha into 2 for comparing p-values. Okay, Madhu, most of these softwares gives you p-value which are for two-tail. So you need not to do anything in this regard. Whatever probability value is there, that is for both the tails, and then you can compare it with 5% or whatever level of significance you're taking. And if you have a one-tail test, then whatever p-value you get, it should be divided by 2 for one-tail test. Because I don't need area on both the sides, I need area on one side, assuming my distribution is symmetrical. So I divide it by 2 to get the half of it for one tail. Pooja, I think the title is Basic Statistics. Okay. What is hello? What is a parametric test? And what is a non-parametric test? And when should we use? Kavita, can you tell me what is parametric and non-parametric? Rajiv. Kavita is saying there is some assumption about the distributional parametric. So for one tail test, how significant the error value is? Ritu, you have to compare your p-value, half of the p-value with your alpha. And the criteria is same. If this is greater than this, reject. Otherwise, accept. Ganga, Sushila, I think there is a lot of confusion about normality. Every test will require assumption of normality. That's not correct. Though most of the tests requires assumption of normality, but it's not necessary that every test is requiring assumption of normality. Gangaji, what you have to say at the most that distributional assumptions, whatever it is, made for the population should be true. No, Madhu, it's not necessary about normal distribution. Yes, Tina is absolutely right. Parametric test is a test for certain assumptions about populations. That's great. And parametric test is a test whose model requires and specifies certain conditions about the parameters of the population from which the sample is drawn. And that assumption may be assumption about normality, assumption about a particular parameter value. You know, all those things you have to find out. Sorry. Yes, majority of the case you'll find it is the normal probability distribution. And any test which is not making any assumption about parameters of the population, that will be called non-parametric. Okay, Ganga, I think, let me explain. The tests which we have, they are either parametric and non-parametric. And as I said, non-parametric tests are based on assumptions. Assumptions are true, then use parametric. If assumptions are not true, then you should use non-parametric. So non-parametric tests are used when you find that you cannot apply parametric tests because the assumptions about the parameters is not true. So that's how we say about parametric and non-parametric. So when data is measured at a scale level and when assumptions about the specific test are true, then we use parametric test. When the data is nominal or ordinal, not measured at a scale level, nominal and ordinal, or the assumptions of the parametric models are not satisfied, then you should use non-parametric test. Okay, so be clear in your mind. If your data is nominal, ordinal, always use non-parametric. If your data is a scale, assumptions are true, parametric. If assumptions are not true, non-parametric. Another important thing when we talk about hypothesis testing is if we have more than one sample, then we have to understand the concept of related samples or unrelated samples. And before that, when we take a sample, Vinaji, are you there? Vinaji, are you there? Vinaja? Okay. Suppose you have taken sample data. Whatever method you have used to collect the data, you have got the data. In that data, you have one of the variable gender that can take a value female, male. I'm just taking two categories for simplicity's sake. You know what I do? I divide my sample into two. One which is related to female, another related to male. Then I will say we have two samples. Technically, we should use the language subsamples, but the practice is we say two samples. Okay. These two samples which you have before you, are they related or are they not related? If they are related, you will have a different test. If they're not related, you will have a different test. Okay, let me take another example. Suppose we want to see the impact of COVID on the income level of the paper. So what I do, I take income level before COVID and after COVID. So I have two samples, one before, one after. Then question is, are they related? Are they unrelated? How do I know? Anyone who has a sense of capturing relatedness or unrelatedness? If you take sample on the basis of before and after COVID, are these two samples related or unrelated? Correlated. Okay, chi-square test. Kavita, I'm not coming to the test right now. That we will gradually move. And correlation. Charu, we are not testing any hypothesis right now. But my question is the two sample data which you have and this, are they related samples or not? And the answer is they are related. Same person, you're asking a question about income before COVID and income after COVID. Same person. So that person is creating a relation between these two pieces of information. On the other end, if you have the female and male, females are separate, males are different, no relation whatsoever between these two samples will be independent samples. Kavita, your question is different. You want to check whether they are dependent or they are not dependent. My question here is not that. My question is, when I decide what is to be done, I must be clear in my mind whether they are related samples or they are not related samples. If they are related, then the question of correlation will arise, otherwise it will not arise. Related samples are defined as those where the observations in one has some relation or influence on those of the other sample. If we are grouping on the basis of a variable, then we say related samples. And how do we visualize this? In a species, you will find a, same. Like fixed time, stock level, no indent pending. These are all related samples, same respondent. Okay, Charu, just give me an example, give me a time, I will. If we take the groups on the basis of designation, then we are talking about unrelated sample. Charu, I think you are working with the banking sector, if I'm correct. पिंटू मैं बाद में बात करूं, अर्जेंट तो नहीं है, मैं बाद में बात करूं. You are working on 500 BSc companies. Okay. What data you have? Charu, you can unmute yourself and talk to me directly.
Yes, sir. Good evening, sir.
Good evening.
Sir, actually, in my study, I'm looking at the impact of the new accounting standard on the quality.
Quality of what?
Quality of the accounting information, sir.
Okay.
Wherein I am going for primary and secondary study both. And I have already framed the questionnaire. And in the secondary study, I'm finding out the value relevance of the variables.
कहाँ से कर रहे हो?
So I'm doing from Bharati Vidyapeeth University. It's in Paschim Vihar.
Paschim Vihar. Okay. Okay. So you have accounting data with you?
Yes, sir. I have accounting data. I've gone through the data from the province, CMI province.
Okay. Then you have data before Ind AS?
Yes, sir. Yes, sir. Before and after. Yes, sir.
And after Ind AS.
Yes, sir. Exactly.
That means 2016, 15, 16 was the cutoff period.
Yes, sir.
Before that and after that.
Yes, sir.
So before and after, that will be related sample.
Okay, sir.
Same company, you are getting the data. Before implementation of the Ind AS and after the implementation of Ind AS. Okay. Now, suppose you want to see the value relevance. Is the value relevance different for different industry? Then you are breaking your sample into groups of industry, and every industry is independent of each other. Then you will have unrelated samples. So if you do the classification on the basis of industry, independent, before and after, that's dependent. That's how we classify related and unrelated samples. चारू, कौन है तुम्हारे सुपरवाइजर? चारू, तो सुपरवाइजर कौन है तुम्हारे? Okay. So let's proceed further. And now we have a question that what kind of hypothesis it is and can we test it statistically? Operating aspects are not considered important for determining dividends for Indian organizations. Anyone can help me in this? Operating aspects are not considered important for determining dividends for Indian organizations. What is the hypothesis we have here? Think of it. And impact of the four operating aspects: tangibility, business risk, operating profit, and size on the dividends of the company. So null hypothesis will be all these four have no impact on your dividend. Otherwise, they have impact on the dividend. And then you can define for each and every aspect of operations and see its impact on the dividends. That will be our null hypothesis. Operating variables do not have any impact on dividends. Madhu, coefficients of operating aspect are jointly equal to 0. Kavita, right, absolutely right. So let's first check with our parametric test, and I will be looking at different conditions where we can make use of parametric test. So parametric test can be used only for the scale level data where the assumptions are true. And I have designed my discussion on the basis of number of samples which we have and how we test them. So if you have only one sample, then if you're looking for central tendency test, then you can use Z or you can use t-test. And if you're checking variations, then you can make use of chi-square. If you're having two samples and they are related samples, then you can make use of pair t-test. And if they are independent samples, then you can make use of independent t-test. And if we are testing difference of the mean and relation between the samples, related, independent, and if variances are of same are equal, then you will have a different test. If they are not equal, you will have different tests. Kavita, where you will use F-test? Anshika, have you taken all the rights back?
No, sir. No, sir. I gave the rights again, but I haven't taken any rights back, sir.
They are saying that we are unable to talk.
Sir, I check again.
Charu is saying no rights.
Sir, they can unmute. I have seen the settings. Settings says they can unmute. Sir, are they able to unmute now?
Kavita, Madhu, can you unmute yourself? Now.
Yes, sir. Yes, sir. But sir, once we unmute, then we cannot again unmute ourselves. It is allowed only once.
Acha.
Sir, settings only allow me to unmute all, so I have done it. I don't know about this other technical parts.
Kavita, why do you say F-test? Where we use F-test? Kavita, where do we use F-test? Okay, muted again. Anyway, Kavita, I will come back to the F-test, but right now I'm not discussing a situation where we use F-test. So if the samples are related, we use a pair t-test, and if samples are not related, we use independent sample test. And of course, you have to also check whether their variances are same or not same.
Sir, in case of t-test, when there are unequal variances,
Right.
can we have the degree of freedom in decimals?
Yes, we can.
So why is it so?
Because the formula which we calculate the combined variance. So when we combine, so it might be possible that the degrees of freedom are coming in fractions because we are taking averages.
Okay. And we are supposed to report that decimal figure as degree of freedom, right?
Yes, yes.
Okay. Okay.
And if we have two samples and we are checking for variation, then we use F-test. So F-test is a test of equality of two variances. So if null hypothesis is variance of 1 is equal to variance of 2, then you can make use of F-test. And both the samples should be independent. That's a condition. And if you have more than two samples, then we can make use of analysis of variance if we are checking for equality of the means. And if we are checking equality of the variance, there we can make use of Levin's test. So now this discussion covers all probable situations of your scale level data. One sample, two samples, more than two samples, related samples, unrelated samples, and whether you are testing for mean or testing for the variation or the variance. Yes, Kavita, joint significance can also be checked by making use of it make use of
So this problem is arising because we have given the unmute rights to all.
Right. Anyway,
Should I remove that or should I continue?
you can.
No, I can't hear you.
Let me unmute this person, Sunil. This is
Dr. Aman and Sunil, are you requested to kindly mute?
Sunil Sudan. Not seeing his name. Sunil Sudan.
Sir, I have manually muted them. Please continue, sir. Sorry for the disturbance, sir.
And now let's see what are the non-parametric tests which we use. Again, my discussion will be on the same lines. We have the nominal data. For the nominal data, one sample and two categories. There we use binomial test. And if you have more than two categories, we use the chi-square. And if you have two samples and they are related samples, and you have only two categories in that, we use McNamara test. If you have more than two, chi-square, unrelated samples, chi-square. And if you have more than two samples and nominal data, related samples, two classes, then we use the Cochran Q. Otherwise, we use chi-square. So you will observe in the nominal data, most of the time we use we use the chi-square test. Ordinal data, okay? Let's see what test we use when we have ordinal data. One sample, goodness of fit, we use KS test. If it is a test related to the central tendency, we use sign test. And when I say central tendency, that's related to median. Because it's an ordinal data, you can have the hierarchy and you can by 50% and get the median. But you cannot have the mean test for the ordinal data. KS stands for Kolmogorov-Simonov test. That's the test of goodness of fit. And when I say goodness of fit, you can check normality by making use of goodness of fit data test. And if we have two samples, related sample, we use Wilcoxon matched pair sign test. So this is parallel to your paired t-test, which is parametric. So you want to use a paired t-test.
Hello.
Because of the fact that
Hello.
Yes.
1 second. Yeah, tell me, sir.
Do you have a question?
Hello.
Do you have a question?
Dr. K. Jigathisan, you are requested to kindly mute if you are not having any question.
No, madam. No, madam. I'm listening.
So kindly mute, sir.
Yeah. I don't know how it has got unmuted.
You have raised hands also.
So you can please continue, sir.
So if you are using paired t-test and you find that the assumption is not true, assumptions are not true, then you can use the corresponding and the parallel non-parametric test, which is Wilcoxon match pair assigned rank test. So please remember this. If you feel that you can use pair t-test, but because of the violation of assumptions, you can't, then use Wilcoxon matched pairs signed rank test. If the two samples are unrelated or independent, then we use a Mann-Whitney test for testing the average value. And in case of scale data, we use independent t-test. And because of some reason, we are not in a position to use independent t-test, then the non-parametric equivalent is a Mann-Whitney test. If you're having two distributions, ordinal data, and you want to check whether both are fitting each other or not, goodness of fit, then you can make use of KS test. And if you are having more than two samples, then we can make use of Friedman test for the related samples. And if they're unrelated, we can make use of Cruxell-Wallis test. And Cruxell-Wallis test is parallel to your ANOVA or analysis of variance, which is applicable in case of more than two samples and you're checking equality of means. So now you can see if parametric doesn't work, what will be the corresponding non-parametric, you can find out. Madhu, for COVID effect on income, which test we can use? Right. So income is a scale level data. Two samples, before and after, related. So we should use paired t-test there. Madhu, is that okay? Any question before we go ahead? before we proceed further? Anybody? Any doubt? Charu, in case of multivariable, I really don't know what you mean by multivariables. Can you give me some example of multivariable? What exactly you want to do with multivariables? Charu, can you unmute yourself and talk? If you have more than two variables, scale level data, then you are checking for mean, you should use ANOVA. And if you are checking equality of the variance, then you should use Levin's test. Okay, Kavita, you're right. First preference is for parametric test. That's my first love for scale data. But I should use it only when my assumptions are true. Because if assumptions are not true, results are not reliable results. So if you have scale data, assumptions of the parametric test which you want to apply are not true, only then you should look forward non-parametric data. Otherwise, go for parametric. They're more powerful, more robust, and their power of the test is also very, very high. Just a minute. Hello? Acha, theek hai. By assumption mean it depends upon the test which you are using. So for the t-test, normality assumption is there. We should have it. Then are we assuming equality of the variance or not? That we have also checked. So all those things we have to check. So it depends upon what kind of test you are using. Okay. Let's see what next we are going to do. We are going to take some examples and see how we can apply it. And I will be doing it on, okay. Do you believe that every pack of Maggi noodles is having exactly 70 grams? Let me check if I get the spaces or not. Okay, can any one of you suggest me what should be the test we should have it here? An experimentation was done and we collected 10 packets and their weights were noted. So what kind of a test I should use? Recall. Just a minute. Let me just open the SPSS file. And mean is equal to 70, one sample, mean test. So here we will be using t-test. So I open up file. Make it data. Open. So here you will find we have one sample scale data, because weight is a scale data, and we can make use of t-test. So go to analyze, then compare means, mean test. The weight is my dependent variable. Sorry. I think I've taken a wrong choice. Go to analyze, mean, one sample t-test. Test variable is weight. Test value is 70. Okay. And that's the result which we get. Sorry. I think I have to share my screen again. And if you see here, the two-tailed significant value, the p-value, is coming to be 0.343. Which is more than 5%. Null is not rejected. Yes, Madhu, what you said. So we have no evidence whatsoever to reject our null hypothesis. That's the result which we get. Let's take another example. Okay. Can we say that students score more marks in mathematics than of the computer science? What will be our null hypothesis? What is the nature of the data and which test we have to use? What is the nature of the data? The scale level data. And marks in mathematics, marks in computer science. Madhu, it's technically it is failed to reject the null. Technically, we should say like that. But in the normal language, we sometimes talk loosely and say accept null hypothesis. But technically, it means you're right. We should say fail to reject null hypothesis. 2 samples and marks in maths, marks in computer science. Okay. And what should we do? 2 samples, which test we have to use? Independent or dependent? Related or unrelated samples? I can close it. Open another file. Yes, who will give me the answer? Madhu, why you say independent sample t-test? Same student, you have the marks for maths and marks in computer science. Same student. The student is same. You are getting marks for maths, marks for the computer science. And therefore we should, yes, Kavita, you are absolutely right. We should use pair t-test. So I go to analyze. Compare means paired sample t-test. These 2 marks I'm taking. I think I should put it somewhere here. And you can see here the p-value is 0.115. That means data is not providing us evidence to reject our null hypothesis. So we cannot say that the marks obtained by the students in computer science and in the mathematics, they are significantly different from each other. Whose anxiety level is normally high, male or female? Which test we have to use? Kavita, please come out. Charu, Madhu. मधु, मैं ये नहीं पूछ रहा मेल होगा ज्यादा फीमेल, वो तो डेटा बताएगा. मुझे बताओ कौन सा टेस्ट लगेगा. Male, female, 2 samples, right? Related, unrelated. Independent sample t-test. Yes, Jigisha, absolutely right. So, let me open up the file. Anxiety level. Gender. So analyze, compare means, independent sample t-test. Test variable is anxiety level. And we have to group on the basis of gender. So groups are 1 and 2. So F-test is for testing of equality of variance. Rejected. That means we have to read the solution corresponding to variances are not assumed to be equal. And then my t value is this. Madhu value, degree of significance is coming in terms of fractions. Total test says 5.562, more than 5%. That means there is no difference in the anxiety levels of male and female. That's what we can say. So my data is not providing me evidence to say, to conclude that the anxiety level of male and female both are different. Which type of company, big or small, has higher return on equity, big or small? So two samples, small and big companies, and independent. Therefore, we should use the two sample independent. Do you believe that trading can improve the typing speed of the office employees?
Situation I request Ananya to kindly mute. Sir, please continue.
Do you believe that trading can improve the typing speed of the office employees? Related samples, unrelated samples. Pair t-test, yes. So I'm not going to do that. That you can easily do in SPSS. You can apply pair t-test. Do you believe that buying a branded battery will have a more life? So if two products are branded and generic, two samples. Unrelated samples. So independent, two sample, t-test will be used in this case. Charu, what's your question? How we have classified big or small on the basis of what? The basis you are asking, Charu? Yes, yes. How to solve. Okay. So I can show you how can we solve it. So I close this. I open a file. Okay. Right, return on equity. Sorry. I have a data of big companies, small companies, P ratio. So we have the size of the companies, big and small, and we have the P ratio. So I go to analyze, compare means, independent sample t-test. My test variable is the P ratio, grouping variable is size, and we define group in terms of 1 and 2. That's how we do it. So I have to check what's wrong, what is. Oh. Code I have to take. One and two. And variance are different, so we will read the result of the second one, and it is coming to be 0.506, more than 5%. Therefore, we did not find any evidence to say that smaller companies are having more P ratios or bigger companies are having more P ratios. And like this, I think you can try improving the typing speed. 2 sample before and after, they will be related samples, and you can make use of pair t-test here. Independent sample, 2 batteries, different. Independent sample t-test. By pack, you can take. Okay. You are a student of class 12 graduate program. Would you like to join a skill development course 1 year? Yes or no? How do we check? Madhu, we can make use of 10%, but normally we don't do that. But if you believe theoretically you are getting a support, then you can make use of 10%. Otherwise, normally we use 5%. And we use consistently 5% throughout. You cannot say for this test 5%, for this test 10%, for this test 1%. You can't do that. You are a student of, we are asking, you are a student of which? And will you like to join a skill development course or not? What kind of data is it? What kind of data is it? What kind of data is it? Nominal data. And we are having 3 groups, 12, graduate program, postgraduate program, more than 2. Responses are yes and no. So nominal data, 3 samples, sample of class 12, sample of graduate program, postgraduate program. So in that case, we will be using chi-square test. So let me open up the file. On parametric test. don't remember where I have the file. I think I have to check. Sorry, I think I have to check the file. It's coming to be same. Okay, let me take this example. So we have the flavor of ice cream, and we want to check which flavor is important for the males and females. So chocolate, vanilla, strawberry, these are the flavor which is demanded by the male and female. So we want to check whether there's a difference in the selection. So we use a chi-square test, and where that is available, I go to descriptive, cross tabulation, and suppose I take gender in the row, flavors in the column, statistics, chi-square, continue. Okay. So the value is coming to be 0.06. That shows that we have a significant difference. So the choice of the ice cream flavor is different for male and female. And where is that difference that you can make out from the table? The cross tabulation. So male 47, female 43, but the basic difference is in chocolate. Female are asking 40, males are asking for chocolate out of and 15 male. No much difference between the strawberry, but the distinguishing feature is the chocolate preference. So there are differences in the preferences, and the main difference is in the preference of chocolate flavor. That you can conclude out of it. Okay, so like this, you can perform different hypothesis testing. Okay, so any questions before we go ahead? So let's take a break, and after the 10 minutes break, we will come back and continue with our discussion. Okay.
Thank you. So dear participants, we are breaking for the 10 minutes and we will continue after 10 minutes. Kindly join on time. Thank you.
I have a question from Kavita. She's asking why chi-square. So Kavita, most 99.9% cases, if you are working with the nominal data, you will find you are going to use chi-square test. Okay, barring few cases where we are using McNamara test and Cochrane Q test. Otherwise, majority of the cases we use chi-square test, whether you have a one sample, two samples, more than two samples, in case of nominal data. And that's the reason I said chi-square. Kavita, is that okay? So welcome to the session on correlation regression. That's what we are going to discuss now. And let's start the session with positive energy. And all the best. And again, we are in a learning mode and it's time for us to learn. And always be curious to learn. And any question before we proceed further about what we have already discussed regarding that. If you have any query, any question, please let me know. No? Great. So we shall start our session with a focus on research. Whatever research one undertakes, he or she has to come out with a research design. And we cannot imagine a good research without a good research design. So you have to design your research and let's enjoy snowfall and wait for my questions to come. Meenakshi Kumawat, I believe you must be from hilly areas. Can you tell me, is it a fall in temperature that causes snowfall or is it snowfall that causes temperature to fall? Meenakshi Kumawat. Meenakshi, are you able to hear me? Meenakshi, what do you think? Snowfall तब होता है जब टेम्परेचर गिरता है या स्नोफॉल होने के बाद टेम्परेचर गिरता है? I think you can unmute yourself if you wish. Snowfall causes temperature to fall. Anuradha Sabharwal.
Yes, sir. When temperature causes when snowfall.
तो टेम्परेचर गिरने से स्नोफॉल हो रहा है और अनुराधा कह रही है कि स्नोफॉल होने से टेम्परेचर गिरता है.
Yes, sir. After snowfall, that causes temperature to fall.
And when do you have a snowfall?
No, sir. So, pardon?
When do you have a small snowfall? When there is a dip in the temperature? Are you from hilly areas? Have you seen?
No, sir. No, sir. I'm from Rajasthan.
Achha. Anyone from hill stations? Just a minute.
Sir, can I answer?
मीनाक्षी पता नहीं मेरे को क्यों लगा कि तुम इलियरस को बिलोंग करते हो.
Sir, can I answer?
Okay. If somebody says it's a fall in temperature that causes snowfall, is right. If somebody say temperature falls after snowfall, that person is also right. So it depends. So if you are in a hilly area, the dip in the temperature causes snowfall. But if you are in Delhi, you will find if there is a snowfall in Shimla or in Nainital or in some other places like that, you will find Delhi is having cold wave and therefore the temperature is going down. So what should be studied? That depends upon the kind of the research design you have. And accordingly, you have to proceed in your research. So you have to ask yourself what exactly you want to prove. There may be bidirectional relationship, quite possible. So are you going to check bidirectional relationship or are you going to check unidirectional? That is something which you have to be clear about. And accordingly, we have to design our research. Before that, Charu was having a question. Charu, you ask, well, how do we decide significant level? I said earlier also, normally we take 5% level of significance. That's a practice followed worldwide. But if you are theoretically sound and you believe that maybe 10% is the right significant level, you can go for it. But normally we take 5% at the level of significance, but we do report if there is a 1% level of significance or not. चारों मुझे बताओ कि डेट इक्विटी का इम्पैक्ट प्रॉफिट पे होता है या प्रॉफिट का इम्पैक्ट डेट इक्विटी पे होता है. चारू क्या कहते हो? डेट इक्विटी का इम्पैक्ट प्रॉफिट पे हो रहा है, प्रॉफिट का इम्पैक्ट डेट इक्विटी पे हो रहा है? Others can also say, others can also respond to it.
Can I respond?
Yes, Anshika, most welcome.
Sir, I feel when a company starts and we finalize a debt equity ratio, we try to finalize based on like our earning power, the estimated earning powers, and the how much the debt the company can have, because we have to repay the debt and the interest is regular to be paid on it. So initially, like that debt equity ratio defines my structure of profits. But if I'm able to have enough profits, I don't need to raise further either debt or like earnings. I can have my retained earnings to finance my projects. So it is a mix of things, and many other factors also work simultaneously for it. So
Anshika, what you will do? You will define your research questions in a way you want to, what is the research problem on which you are working. Suppose you are saying determinants of the capital structure of a company, for example. So don't you think you will take profit as one of the variables?
of course I will take, sir. Yes, I will.
Depend करता है कि आपका impact क्या है. अगर आप impact अगर आप evaluate कर रहे हैं firm performance को, तो firm performance की evaluation में आपने एक measure लिया return on equity, तब भी आप debt equity ratio को independent variable लेके चलोगे. तो किस तरह से आप अपनी रिसर्च को डिजाइन कर रहे हैं, उसमें बहुत बहुत important है उस चीज को ध्यान में रखना. So you have to be very careful about the way you design your research. That is the point which I am trying to say.
Yes. Yes, sir.
Look at this. Okay. Is lightning that causes thunder, or is it thunder that causes lightning? What is the cause of lightning? Thunder, or thunder is causing lightning, or is it the lightning that causes thunder? Charu, thunder causes lightning nahi hota hai. Anyone with science background? It's not thunder that causes lightning. It's the lightning that causes thunder. And what causes lightning? Anyone? What causes lightning? No, राकेश जी नहीं, थंडर नहीं है. साइंस कहती है कि जब दो तरह के क्लाउड्स, जो एक पॉजिटिवली चार्ज है और एक नेगेटिवली चार्ज क्लाउड है, जब वो दोनों आपस में कोलाइड करते हैं तो लाइटनिंग होती है. उस लाइटनिंग से थंडर होता है. Frictions. So when they collide with each other, the positively charged cloud and the negatively charged cloud, then electron exchange. Yes, absolutely right, Falguni Patel. So basically when they have charge and they collide with each other, so there is exchange of the electrons, and that causes lightning and that causes thunder. You know why I'm talking about all this? When you work with your problem, you should be clear about it, and accordingly, you design your research. You design your data, what data you need to answer that particular question, and what tools you are going to use to answer those questions. Understanding of the problem is very, very important. Mystery behind cause and effect. When one event causes another to happen, the cause is why it happens, and the effect is what happens. Ninja, thunder doesn't causes lightning, it's other way around. Yes, Falguni, you're right. It's like snowfall issue, which we have discussed. Because what you see may not be the reality, because we hear thunder later on and lightning first. So the gap between we have, so we can say that because of the time gap, we find that thunder is happening after lightning. But in fact, both are happening, both are occurring, both the events are happening at the same time. Okay. The purpose of this discussion is orient ourselves with the research mindset and learn correlation and regression with the mindset that we are going to use for our research. And we shall begin first with the correlation. In this session, sorry, not morning. In this session, we are going to concentrate on the following kinds of research: associative, relational, correlation research, and causal research. This you can answer through correlation, and this you can answer through regression. So first we shall start with associative or relational research. So we are looking for relations between the variables. We are not saying what is cause, what is effect, but we are saying, is there any relation between the two variables? A measure of association is a numerical index, is a number that summarizing the strength, degree, and direction of the relationship. What does it mean? We talk about a strong relationship, weak relationship, moderate relationship. So if I'm using this kind of terminology, strong relationship, weak relationship, moderate relationship, then I'm talking about strength of relationship. Then direction, whether we have positive relation or negative relation, that talks about direction. And the number which we get, 0.25 minus 0.60, that's the degree of relationship. Okay. Now let me ask you a simple question. There are two children in a family. Do you see any association in the level of their education? Two children in a family. Let me name them as A and B. Do you see any association between their education level? अंशिका क्या कहते हो?
Sir, we need to check, like we need to check because it may vary from family to family and children to children.
अगर एक बच्चा पढ़ रहा है तो दूसरा भी पढ़ता है.
No, not necessary, sir. We have to check
Not
the
necessary.
association.
I agree with you, but normally it happens.
Okay, okay. Sir.
And suppose you find that the education level, there is association among the children in the same family. Relationship may not be very strong, but say 40%. Can I say the education of B children causes the education of A children? Can I establish the relationship, cause and effect? I cannot establish a cause and effect relationship, but I do believe कि दोनों में कहीं ना कहीं कुछ association तो होगा. एक पढ़ रहा है तो दूसरा भी normally पढ़ता है. So there may be instances where you have relation, but you may not have cause and effect relationship. There are quite many examples where you find cause and effect relation. Let me take another example. Suppose in a family, a child born, right? And family was very happy. They planted it.
Requested to kindly mute.
So the height of the child is increasing, and
Poonam ji, you are requested to kindly mute.
the height of the child is increasing, height of the tree is increasing. If you find the correlation between them, you will find a positive correlation. But I cannot say one is the cause of the other. So you may say relation, but may not be cause and effect relationship. That means, however strong relationship you have, it doesn't mean that you have cause and effect relationship. And there are so many examples where association was observed, but there was no cause and effect relationship. So when you are studying correlation, please be clear in your mind. Are we talking about simple association, or are we talking in terms of cause and effect relationship? A measure of association correlation represents the mutual relationship between two variables. So first, let's see how do we get the measure of association for nominal variable. Sorry. First, we have to understand what is the meaning of association between a nominal variable. Check. Suppose I take an example. Say I take a gender, male, female. And we have another data that's called, say, shopping online. Yes. No. So we have two variables, shopping online, yes, no, and gender, male, female. Shopping online, yes, no, my nominal data. And gender is also my nominal data. And I want to see whether there is any relation, any association between the gender of a person and its tendency to buy online. I want to study that. And both the data are nominal data. Okay, first. Can this association measure between the nominal data have a direction? Can you assign a direction to it? Positive, negative? Can I say negative relation or positive relationship between these two? No, because nominal data doesn't have any order. So you cannot say increasing, decreasing, positive, negative. When you calculate a measure of association among the nominal variables, it has no direction. So its value always lie between 0 and 1. So it has only two things. One, the degree, the number, and on the basis of that number, you can say strong relation or weak relationship. And we use chi-square test for measuring association between nominal data. But the problem with the chi-square is that does not provide degree of relationship among the variables. It only tells whether relation exists or it's not existing. Dependent or independent. Only that thing it says. But what is the degree of relationship? Chi-square doesn't tell. And it's also sensitive to sample size, and which makes comparison difficult. So in place of chi-square, we use a measure which is called Kramer's contingency coefficient, and that's the way we calculate this. So I'm not going into the formula for it because we use SPSS to calculate Kramer's contingency coefficient. And these are the possible thumb rules which we have defined for relationship. Negligible association, weak, moderate, fairly strong, very strong relationship between the nominal variables. Anybody working with the nominal data? Anybody? Charu, did you collect primary data? चारू प्राइमरी डेटा कलेक्ट किया तुमने क्वेश्चनएयर से? कोई क्वेश्चन बताओगे नॉमिनल डेटा के? कोई 2 क्वेश्चन तुमने पूछे हो नॉमिनल डेटा के? Charu, I think you can unmute yourself. Profession, okay. What next? Any other question? Any other question? Okay, और कोई डेटा बताओ? ऑर्डिनल का बता दो मेरे को. राकेश जी, वेदर में क्या चीज आप लोगे? वेदर तो टेम्परेचर से, ह्यूमिडिटी से, प्रेशर से डिफाइन होता है, तो सारे नंबर्स हैं. चारों ऑर्डिनल नंबर का आइडिया दो. एक स्टेटमेंट बताओ मेरे को. कोई स्टेटमेंट बताओ मेरे को. चारों ये कोई क्वेश्चन है? इंडिया में तो फेयर वैल्यूएशन होता ही है. तुम क्या पूछ रहे हो उसमें? ये कोई क्वेश्चन थोड़ी होगा. इंडिया में तो फेयर वैल्यूएशन है ही है, और एएस में वैल्यूएशन था ही नहीं फेयर वैल्यूएशन. ये कोई क्वेश्चन थोड़ी होगा. Okay, are you aware of the social media applications used by your children? Right. Okay, and suppose you ask parent, working, non-working, one variable. Second, awareness about the use of apps, social media apps by the children. Yes and no. So do you see any connection, any relation between the awareness of the parents about the use of social media apps and their nature of whether they are working or non-working? There you can make use of Kramer's contingency coefficient and find out if there any correlation between working status and the awareness. Yes, Jigisha, you can do that. Charu, the question which you are asking is not a right question, whether it's a part of the questions or it's not a part of the question. Okay, let's see ordinal data. Like here, gender and occupation, and which outdoor entertainment you most like. So I want to see, is there any relation between the marital status and which outdoor entertainment they like. So for that, you can make use of Cramer's rule, null hypothesis, no difference. And we use the Cramer's phi. This is 0.371, significant. Yes, gender and choice for entertainment, option, they are highly correlated with each other. And if you see the data, you will find females, male like to watch movie in a theater, and outdoor adventurous experience. On the other hand, female out of 105, 45 like to go for the shopping in male. So yes, gender does have impact on the choice of entertainment that you can conclude out of it. Let's say ordinal data, where we work with the ranks or preferences and ranking. So for that, we calculate Spearman rank correlation, if you remember. This is used for ordinal data. Second method is what is called Goodman-Cruxell gamma. That's how we this is the pairs of agreement, pairs of disagreement. So if the pair of agreement and the pair of disagreement are same, that there means no agreement, no relation. If the people agree more as compared to disagree, positive association. If they disagree more than they agree, then we say we have a negative association. And it's an ordinal data, so it has an order, decreasing or increasing. Here you can talk about positive and negative correlation. You prefer that your life partner's family should be financially sound, and we have given the ratings. Love marriage is better than arranged marriage. Again, we have asked them to rank. So both are ordinal data, and we take the correlation between them, ordinal by ordinal gamma, negative, significant. That means you prefer that your life partner's family should be financially sound. I say strongly disagree. If I move here, then I move here, strongly agree. So love marriage is better than arranged marriage. I say strongly agree. So those who believe that love marriage is better than arranged marriage, they are disagreeing with life partner's family should be financially sound or not. Financially sound. So that's what you can conclude out of this. And if you have the interval scale data or the ratio scale data, there you can make use of our famous measure of correlation, which is called Pearson's correlation coefficient. So nominal data, go for Cramer's phi, Cramer's v. Ordinal data, rank correlation or gamma. And if it is scale data, you can make use of, Pearson's correlation. Okay. Do you see any association between the degree of a student and the measure opted? And that's the frequency which we get. कुछ एसोसिएशन है क्या इनमें, डिग्रीज में और ऑप्शंस फॉर मेजर में? Let me take another example, then we will go to the क्रेडिट रेटिंग में और ओवर सब्सक्रिप्शन है नहीं है, उसमें कोई रिलेशन है? Can I say that higher the rating, higher will be the subscription? Can I make that kind of comment? To do that, let's take data and see how can we calculate it. Let me check how. So friends, you have to be friendly with your data, understand your data. Okay, that's different. I have to see which file I have to open. Yes. So we have degree, we have the measure, we have the frequency. What is the role of frequency here? What does it mean? When I say frequency, what does it mean? BBA, accounting, frequency 78. What does 78 means? You will give me the answer for it. Catch is the 78. Number of students. That means 78 number of students are in this particular combination. That means what? This combination should get a weight of 78. Second combination should get a weight of 33. Last should get a weight of 8. So these frequencies are basically nothing but weights for each group. So when you process this data, you have to first define weights of this data. So go to data, weights, cases, weight cases by frequency. Okay. And the moment you say weight, you will get a message here, weight on. That means now the observations will be weight as per the frequency. Now, let me make the cross tabulation. So go to analyze. Descriptive statistics, cross tabulation. Degrees I'm taking in rows, measure in columns. Degree is a nominal data, And measure is also my nominal data. So I have to select a test which is contingency, which is phi Kramer's fee. Simply say continue. Okay. Significant. That means what? How do we read this result? There is a very strong relation between the degree a student is having and the choice is making for the major. And what is that relationship? The relationship is the BBA people are primarily going for accounting and finance. MBA people going for others. DBA people are going for others. That you can read from this particular table. So even if you have the nominal data, don't worry, you can still calculate the association between them. Okay, now let me take the rating data. I hope I should have the rating data here. Okay. I really don't know whether we okay, let me, I'm not able to find the file of rating data, but can you tell me what I should use here? Credit rating and public response. This is my ordinal data. I can say high rating, low rating. I can put them in order. Response is also ordinal data. So there you can use either gamma or Cruxel and Wallace gamma, or you can make use of Spearman rank correlation to find the relationship between them. Workers stay in the organization 1 to 2 years, 3 to 4 years, 5+, and motivation level. Is there any relationship between the motivation level and the frequency of their stay? Let me check if I have data with me or not. I don't know. I don't have the data right now. Anyway, here you can make use of the rank correlation or other things. Do you see any relation between midterm marks and the end-term marks of the students? Which correlation measure you will calculate here? Marks are scale level data, so I can make use of Spearman correlation. So I have the midterm marks and the final marks of the students. So go to analyze and correlate, bivariate correlation, students marks, final, Pearson's, and there is a significant positive correlation between them. That means those who are scoring good marks in the midterm, they are likely to score good marks in the end term. That's what it includes. How many hours average do you sleep during need time? Are you able to retain the content taught during the lectures in percentage? I want to see, is there any impact of this sleep during night and on their retention during the class in the daytime? Who will give me the answer? What correlation measure I should use here? What kind of the data we have here? Quick. Anybody? थक गए तुम लोग लगता है. Huh? Sakshi is saying, is it interval scale data? Sakshi, no, it's not interval scale data. It's ordinal data. Because when I codify it, I will codify it like 1, 2, 3, 4, 5. Though it looks like interval, but actually it's not interval scale data. When you codify it, you will say 1, 2, 3, 4, 5. So there is a hierarchy in it, but I cannot say 1 plus 2 is equal to 3. I can't say that. So it's ordinal data, and ordinal by ordinal, you can make use of gamma. And let's see, how do we do this? So we have sleep hours in the night and the effect of the sleep hours on the retention rate. So go to analyze, descriptive, cross-step, sleep hours here, percent content here, statistics, ordinal by ordinal, gamma, no significant relationship. So it shows that the sleep hours which you have in the night may not have any impact on the retention rate in the class during the daytime. And please understand important role of the correlation, and that is it tells how much of the total variation can be explained by the other variables through R square. And we all know that R square represents variation explained. And this is true for Pearson's correlation. And not for any other correlation measure. For the Pearson's correlation, If you take a square of it, it will explain how much variation can be explained between them by using these figures. Okay. So now I think you'll be capable of handling challenges of association, correlation. Any question here? Any doubt, any query? Regression thing I will take tomorrow, right? We don't have much time to talk about regression, that we will take next time. If you have any question, any doubt, please don't hesitate in asking questions. Whatever we have discussed today, first session, this session, any questions if you have? No? So Arshika, that's all from my side. And I really thank to the participants. Thank you very much. I can share my email address if you wish. That is okay. Great. So thank you everyone. And Anshika, do you want to say something?